Today we will start the remaining portion of chapter 2, that is biasing of transistors. Biasing means we know transistor can be used for two purposes. The first of it is used as a switch or for the purpose of switching, and second is for amplification. Means in the first portion, the transistor is used as a switch. It will either make the signal to pass through it when the switch is on, or it will block the signal. The signal will not pass through it when it is off. So it will act as a switch. And the second and the most important application of transistor is amplifier. Transistor is used as an amplifier. When the transistor is used as an amplifier, we have to give some voltage. That is exactly as you have taken your breakfast today morning. Why you are taking your breakfast? To make you ready to do the work. In the same way, we have to put batteries or we have to provide some DC voltages to any electronic device we are using. Transistor here is used as an amplifier, which is an electronic device. Its purpose is to amplify weak signals. Amplify means enhance the amplitude. If a small signal will be given having small amplitude, it will be amplified to its amplitude to be bigger by the amplifier, by the transistor. So mostly we will study the transistor used as an amplifier. So for a transistor to be used as an amplifier, it has to be given some DC voltages. Providing that DC voltage is called biasing. First of all, we will see why we are doing biasing or why biasing. We are doing biasing to achieve three purposes. The transistor will be used as an amplifier. Let's take the common emitter configuration of a transistor. Common emitter configuration is, this is the common emitter configuration. This is common emitter NPN. Some weak signal will apply at the input side, and the enhanced amplified version of the signal will be obtained at the output. The transistor will be used as an amplifier. So to use this transistor as an amplifier, first of all we have to achieve three things. Before applying the input signal, we must ensure that the transistor is able to provide zero signal collector current. Now collector is the output. There will be some output before applying the input signal. This is the test purpose. Means the transistor is now ready. It will provide any signal. It will be amplified by the transistor, and the amplified version will be obtained at the output. So before applying any signal at the input for application, we must ensure that in a common emitter configuration, because mostly transistors are used in common emitter connection. So flow of zero signal collector current. We put a proper flow of proper zero signal collector. Zero signal means without applying any input signal. Before applying input signal, there must be some collector current flowing at the output. It means that the transistor is ready for application. And the second is maintaining proper base emitter voltage. This is the base, this is the collector, this is the emitter. So base to emitter voltage, actually this is a PN junction. Base to emitter is a PN junction. That PN junction is to be forward biased. So forward bias means we have to apply some biasing voltage. So that VBE is to be maintained. Why this is required? Because a transistor, a diode will be on when the applied input voltage is greater than the cut-in voltage. So when the applied voltage is greater than the cut-in voltage for a diode, the diode will conduct. Otherwise it will not conduct. So that voltage VBE, base to emitter is a diode. This is P, this is N, this is a PN junction diode. For a PN junction diode, the applied voltage or the base to emitter junction voltage must be greater than the cut-in voltage. Then the diode is in on condition. So that is the second requirement. VBE is to be. So this is about collector current is IC. This is base to emitter voltage VBE. If these two conditions will be satisfied, then the third condition will be automatically satisfied. That is collector to emitter junction. That is also a junction. Two junctions are there in a transistor or two diodes are there in a transistor. So the second diode is also to be made on. So third condition is maintaining minimum proper collector emitter voltage. DCE. So these three things we have to ensure before applying a transistor as an amplifier. What are the three things? Zero signal collector current IC must be flowing. Base to emitter voltage must be greater than the cut-in voltage of that PN diode. Collector to emitter voltage must be greater than the minimum value of DCE required to make that diode work. These three things are to be maintained. So when we are satisfied that all these three conditions are properly maintained, that is called biasing of transistor. Because we have to achieve all these three things. To achieve all these three things, we have to apply minimum two voltages. One is the base to emitter voltage, one is collector to emitter voltage. If these two voltages are applied properly, then a collector current will flow in at the output side. These three conditions to be satisfied for a transistor when it is used as an amplifier. For this purpose, to achieve all these, we need biasing. Then what is biasing? Now we will go to the definition. Biasing of a transistor is basically providing some external DC voltage to achieve all these three conditions. So what is biasing? Biasing is a method, is a process in which we will apply. It is a method of applying external DC voltage to achieve zero signal collector current. This is the first requirement. Base to emitter voltage VBE, and third is collector to emitter voltage. These three things we have to achieve by applying some external voltage to both input side as well as to output side. Actually, we are applying to the base point and to the collector point. Before applying any signal, the signal which is required to be amplified or the purpose of the amplifier is not being done here. Before that, prior to using a transistor as an amplifier, we have to make the transistor ready for amplification. Ready means we have to take our breakfast. We have to take our food. So that food is provided to the transistor to make it ready by the process called biasing. By biasing, we will achieve these three things. Now we'll see what are the different types of biasing. Usually there are four methods of biasing. Actually, one is developed from the other. The very first one is not practically used. The last one is practically used in all purposes. So the four different methods are: first is called base resistor method of biasing. Second is called emitter bias method. Third is collector feedback resistor method. And fourth is potential or resistor divider method. These are the four different methods of transistor biasing. We go one by one. So first we'll go to emitter bias method. the circuit which is used for providing the VBE and VCE. What else is new here? We have connected two resistors, one to the base, one to the collector, and both are supplied with a supply voltage, that is VCC. If we will apply a supply voltage here, then the current will flow like this. Another current will flow like this. In this way, a voltage will be developed at the base point, a voltage will be developed at the collector point. So this voltage will provide VBE and this voltage will provide VCE. Now if we will apply a signal here, that is input signal, its output version will be the amplified version which is obtained here. So before applying this input signal, we have to provide a voltage VCC which will provide base to emitter voltage VBE, collector to emitter voltage VCE, and without applying this signal, a current IC will flow here. So this method of biasing is called the emitter bias method. It is very easy to remember because we have started from common emitter transistor configuration in which these two resistors were not there. Common emitter configuration, only emitter is grounded. Input is applied between base and emitter, output is taken at collector and emitter. So the first biasing method is emitter bias method, in which we have to apply two resistors, one at the base, one at the collector. The current flowing through the, and we have applied a supply voltage VCC here. This voltage will provide a current flowing like this, another current flowing like this. These two currents will provide some voltage at the base point, that is the base to emitter voltage, at the collector point, that is VCE. Because of these two voltages, a current will flow here, that is IC. So all the three conditions are maintained. Now the transistor is ready for any input signal to be applied. It will apply a small signal, it will be amplified at the output. Transistor is used as an amplifier. Now we will go to the next method. So this is the first method. This is called base resistor method. Base resistor method, because we are providing a resistor at the base point. Why this collector resistor? RC is the collector resistor. That is for the output. Any input we will apply here, the output will be developed here. So this can be called as the load resistor. That is the output resistor, collector resistor, or that can be called as the load resistor. So we are providing one resistor at the base point, that is RB, called the base resistor. Because of that base resistor, this biasing method is called base resistor method of biasing. Second, emitter bias. So this is base resistor biasing method. Second is emitter bias. In emitter bias, along with these two resistors, we will provide another resistor at the emitter side. So what will be the circuit? And the base is grounded. We can take the output here. Where to apply the input? Again, input is to be applied at the base. At this point, we will take the output. What is different from this to this? Instead of putting or applying a voltage to the base point through a resistor RB, we have applied another resistor or put another resistor in the emitter side. That is called the emitter resistor. That emitter resistor will provide a voltage at the emitter point. Here base is grounded. Emitter is also grounded, but after the resistance Re. So some emitter voltage will be developed here. The difference between base to emitter voltage will be properly maintained. And similarly, the supply voltage will provide the collector voltage. That voltage and the voltage at emitter, the two difference of these two voltages is your VCE. Because of these two voltages, a collector current will flow here. So all the three conditions are satisfied. And this method, as we have provided a resistor at the emitter one, this method is called emitter biasing method. Here base resistor is provided, here emitter resistor is provided, along with whatever was there in the first one. So the second method is development of the first method, in which the base is grounded and additionally one emitter resistor is put at the emitter. So the second method is developed from the first method. Now we will go to the third method. Third method is collector feedback bias. In collector feedback bias, this is a base resistor, this is the collector resistor. Come to the first one, base resistor method. In base resistor method, a resistor is put in the base. In collector side, one resistor is put, emitter is grounded. Here the same thing is done, but the base is again connected to the collector side. From the base resistor method, here the base is connected to the collector side, to the collector point. That means whatever voltage will be developed at the base point, that will be fed back to the collector. Therefore, this is called collector feedback bias. Here we can take the output. Here we can apply the input. Here we will apply the input. Here there will be the output. This will be the emitter current. This is the base current. Here the current will be IB plus IC, and this will be the collector current IC. So some of these two currents are coming here. One part IB is coming in this way. This current is IB. This current is IC. So total current IB plus IC is provided by the supply voltage VCC. Here we are applying the same supply voltage VCC that will provide all our three requirements. One is the base to emitter voltage, second is collector to emitter voltage, and third is collector current IC without applying any input signal. So this method is called collector feedback bias method. Actually there is another method which is called the voltage divider method, which is most practically used. It is always used. That fourth one is voltage divider or potential divider method. Voltage divider bias. Again, this is developed from the first one, base resistor method. And the method is Now come to the emitter bias or to the base resistor method. You'll see here the base resistance RB we have applied in the first case, that is divided to two resistances R1 and R2. These R1 and R2 are in series or parallel. This is the voltage applied. The current is flowing like this. Another current is flowing like this. So when we will apply the input signal here, input signal will be applied here and the output will be taken here. This is the collector point, this is the base point, this is the emitter point. These two resistors R1 and R2 are connected at the input side and these are coming, it will go from this point this way, then these two are coming in series. The current flowing in this way is VCC because this point is ground. So from positive plate of the battery, we are going to the negative plate. Current flowing in this way is VCC divided by R1 plus R2. And voltage across this R2 is current into resistance R2. So current is VCC by R1 plus R2. This is the current flowing in this way. Same as the current flowing in this way. This is the current flowing to the ground. Voltage divided by total resistor. And the voltage across this resistor is current into resistance. This is our VBE. So VBE is maintained in this way. Similarly, if we go in this way, VCE will be maintained. So we are getting VBE, we are getting VCE, and we are getting some current flowing at the output side, that is the collector. So this method is the most practically used method of biasing a transistor. Before using the transistor as an amplifier, we have to make it ready or we have to bias the transistor. That biasing can be achieved by these four different methods. This is all about biasing of a transistor. Question is coming in the examination either of 5 marks, 6 marks, if that will be a long question, in which what is biasing will be a part question, the need of biasing is a part question, say 2 marks, and explain any one method of biasing or a particular specific method of biasing will be asked. Either the question will be explain what is emitter bias method, 2 marks. So 2 marks, what is biasing, 2 marks, what is the need of biasing, and the rest 2 marks about any of these 4 methods. Or if first 2 questions, part questions will not be there, then explain all the methods of biasing. So you have to write the diagram. Again you have to write what is the need of biasing and how these are achieved through all these 4 methods. And all these 4 methods you have to describe. This is all about transistor biasing.